green materials from RISE. Yes, last week you and Decade started on the 8th, and this is a good timing for the opening of this test site in the way of looking forward in the future towards sustainability. My name is Pierre Ingmarsson. I work as a senior project manager at RISE, and I will be your host for this event. I will take you through on a tour on the test site, as you can see in the picture. This is our new site that we have developed over the year. And you can see in the background, you can see Frdric, a local town close to this research center. And the main building is the research center of Kristineberg Center. And then we will go on the docks. So we will have a few introduction speakers, and then we will go down to the test site, where we'll have a reporter who will talk to the interview some of the researchers, and then we'll go into a studio to talk to some of the companies and what their needs are and what the future looks like. In the third session, we will discuss how do we create collaboration around these themes, around materials that goes into the ocean. How do we make sure that nothing ends up in the ocean that doesn't belong there, and in the same time develop those technologies that will make our future possible for many of us. So I will leave it to the floor shortly and introduce some of the interest speakers. And I would like to introduce Olivier Rod from RISE, who's a department manager for corrosion. He's one of the champions at the RISE that promotes blue growth, and one of the guys behind the scene to make this test site happen. So I'll leave the floor to Olivier Rod. Please go ahead.
Thank you very much, Pierre, for the kind introduction, and good morning, ladies and gentlemen. As you said, Pierre, I'm the manager of the corrosion department at RISE. And as a research institute, our mission is to develop competitive solutions and tools for a sustainable society and sustainable future. And we know that this will necessarily include a sustainable exploitation of the ocean, can be regarding energy, transport, food production, and this will imply that we will have a tremendous increase of the infrastructures at sea in the future. And for this, we need to secure that we have reliable, robust, and environmental friendly materials. And this is exactly what we will do here at Kristineberg. Use our infrastructure's capacities for testing, verifying, developing materials for marine application. And you know, at RISE, we strongly believe that this type of test and demonstration arena is very important. It's a platform to perform testing and expertise in direct collaboration with industry, and also to conduct advanced research projects. For example, Horizon Europe project, implying collaboration with many European partners. And collaboration, this is really what Kristineberg test site is all about. It's a physical test place coupled with a broad network, cross-sectorial, cross-disciplinary, based on which we can create and develop fruitful collaborations, both with the industry, with the academy, with the public sector, and with other international testing centers. And you will have example of these collaborations today. So, ladies and gentlemen, on the behalf of RISE, I'm really very happy to welcome you all to the inauguration of this test and demonstration site here in the west coast of Sweden in Kristineberg. Welcome. Back to you, Pierre.
Many thanks, Olivier Rod. Our second speaker for today is Frdric Granlund. He's the station manager at Kristineberg Center. And if there is anyone, I would say on the planet, that if you want to talk algae, this is the guy to go to. And let's hear a little bit word from the station manager, Frdric, and I'll leave the word to him.
Okay, thank you very much, Pierre. And I could say I represent two institutions today. One is that I'm currently the station manager for Kristineberg Marine Station, and that is Gothenburg University. But most of my time I work at the Royal Institute of Technology in Stockholm, KTH. And we are very interested in material science at KTH. It's one of the very important research areas that we have at KTH. KTH is also a part of the Kristineberg Center, and therefore I'm very happy today to be on this inauguration of this test and demonstration site for marine materials, because this will also be very attractive for researchers at KTH that would like to work with marine materials connected with the marine environment. The future will be in the sea, and in order to reach a sustainable planet in the future, we need to focus more on what we could do in the sea. There will be more aquaculture in the future. There will be more energy systems out there. There will be more use of biomass, as you said, algae, for developing new materials. And all these things, materials that are in the sea and are going to be used in the sea, needs to be tested. And I think this is a very strategical choice from RISE, that is also a partner in the Kristineberg Center, a very strategical thing that we have now at Kristineberg. And it fits very well with Kristineberg's plan to be an active hub for blue growth and blue innovation in Sweden and international. So I'm very happy and I'm very glad that RISE took this initiative. And for that, yeah, I think I'm happy to say thank you and welcome to everyone for today's inauguration.
Thank you, Frdric. And I would like to welcome Jan-Olof Johansson. He's the chairman of Lysekil Municipality. And he is one of the people that is the reason that Lysekil is one of the hot spots in Sweden on the west coast for testing renewable energy, for example, and test and demonstration. I'll leave the word to Jan-Olof Johansson.
Thank you. In Lysekil, we already have one test site in a place called Islandsberg. And Islandsberg test site, it started with testing technology for wave energy. And with this new test site, it will be a great complement to that. Lysekil has an ambition, and our ambition is to be the leading marine center in Sweden for marine biology and technology connected to blue economy. And together with Kristineberg, the Gothenburg University, KTH, RISE, and many other partners, we are doing rather well, I must say. In Lysekil, we have education, both in secondary school and many universities here who are the leading universities when it comes to marine biology. We have many research companies here, and we also have a public arena called Havets Hus, the Ocean House, where we can show people both the marine life in the ocean, and we also like to show what RISE and universities and Kristineberg are actually working with to increase the interest in Sweden. So if you haven't visited us in Lysekil, you are most welcome to come here. Thank you.
Thank you very much. And the next speaker, I would like to welcome Jessica Lawson. We have heard a little bit of the local. Now we're bringing up the perspective a little bit. She's working as a senior maritime expert for the region of Västra Götaland. And she represents one of the major clusters in Sweden working with blue growth, and which is a job that started in 2012. And I'll leave the word to Jessica to say a few words from the region.
Thank you very much, Pierre. It's great for me to actually be here on site today, and I have the test site that had been inaugurated today just behind me here outside the window. So it's a great sunny day here, so it feels great to be out of the home office. We've been working with the region of Västra Götaland, we've been working within the marine and maritime sectors for over a decade now. And it's a really important area of business and research for us in this region. And we see great potential here. So in our newly adopted regional development strategy, strengthening capacity for innovation is one of our priorities, 1 out of 4 priorities. And one important part of strengthening capacity for innovation is test and demonstration sites, which is also something that we've come across as important when we talk to businesses, that there is a need for access to test and demonstration sites. And within our smart specialization strategy that we are developing right now, will be finished early this fall, we are pointing out bioeconomy and biomaterials as something very important to look into in the future, not only biomaterials, but materials in general. So the theme of this test site, the competence and the crew around it, and all the companies and the research that's connected to it now and hopefully in the future, is right on spot for what we consider is important and something that can contribute to sustainable development and the transition that we need to a sustainable and fossil-free society. So I'm very happy to be here, and I wish you all the best with this new test site. Thank you.
Thank you, Jessica. And now we will even move the perspective even higher, and we will welcome Matthias Suede from DG Research and Innovation at the European Commission. He's been working there over well over 10 years supporting blue growth, and especially ocean energy, I would say. And I think he has the perspective to take us into the future. So please welcome Matthias Suede.
Thank you, Pierre. You can hear me? I see I'm mute, but okay. Thank you, Pierre. First of all, I would like to congratulate you with the new test center. It is, I think, very timely. I think it's very great that you are offering this, because it's really helpful, I think, as well, in support of the implementation of our ambitions with the Green Deal. And as you all know, we have set a target for 2050, which is a long-term, to decarbonize our economy and to really think as well to combat climate change. Part of our policy here is to establish a circular economy. And when you think about that, materials are coming in. What are we doing? Whatever we do on economic activities, there are some materials which we use. And it will be important that we really think about what materials are we using, how are we using, in which environment are we using that. And we can only know that when we measure, we test. That's great of, I think, having now this new test center. It's really for the blue economy. And I think also when you look at, you were saying about the future perspectives, it is, you were saying blue growth. But just 2-3 weeks ago, we published a new communication on that, and we said we should need a sustainable blue growth. Whatever we develop new, we have to know what will be the impact on the environment. The materials are we using? Is it really circular? Are we doing it circularity by design? And only numbers will tell the tale, and numbers will help us with decision taking in where to invest. Do we have to invest more in ocean energy, in the offshore, in the blue growth, in the aquaculture, that we do it in the right way? Again, I hope a fruitful opening. Congratulations again. And we really like to see that you are, in fact, leading as well in Europe this idea the materials testing, because it's really in the core of so many different activities. Thank you.
Thank you very much, Matthias. Now we heard a little bit from the local perspective. We've heard a little bit on the regional perspective. We heard of the European perspective. These are the perspectives that we need to stay on course. But behind all those strategies and those perspectives, we need to do some research. We need to do the work. So now we'll see if we can get a good connection with the test sites. So let's go down to the test site, and Simon, he will talk to Christian Anderson and on marine composite. And I'll leave, I hope we get a good connection to Simon on the docks. So I'll hand over to the test site. Okay, it seems like the weather situation on the docks has created a bit of a slight problem to get a connection with the test site. So I think we're inviting Christian Anderson, who's the engineer for polymer and composite at RISE, into the pop-up studio instead. So he's been running up the stairs, a bit exhausted perhaps. So I turn over to the pop-up studio. So Christian, please tell us why composite materials is so important and how it plays a role in the marine environment.
Yes, hello everyone. Let's try this again then. Composites, it's very important to test composite material in the marine environment due to that to get an understanding on how, for example, the chemical or biological or the physical degradation are acting on the material. And why is this important? Yeah, this is important, for example, when you want to have a product that has a lifespan of 10 years in a marine environment, then you want to know that the mechanical properties of this material is passing a 10-year lifespan without degrading too much. And be able to test the materials in this kind of fashion is very good, because you can test a lot of materials at the same time to make a screening on, okay, what kind of materials is passing the requirements that you are putting on the product, on the material. And it's very important as well in material development. For example, if you look now, we're looking more and more on sustainability. We want more sustainable materials inside the composites, and by having this chance to test the material way before when the product is in the lifetime of a product, in the materials in the lifetime of a product, then you can see, okay, we need to make it more durable against chemical degradation or physical degradation. Is the interface between the composites fibers good against the matrix, or is it that place that is lacking strength or whatever? So it's very important. That's what I would say, more or less. I cannot hear you now, Pierre. Unfortunately.
Thank you, Christian. I would like to welcome our next speaker then into the session, and that is Antoine Bunal from Core Power. And Antoine has been working for a demonstration on Core Power. It will be set next year, and then also a C4 testing this year in Portugal. And the composite hulls, Antoine, what would you say is important for Core Power in the future when it comes to composite in your hulls?
Hello, Pierre. Hello, everyone. So yes, I'm representing CoPower today. We are a wave energy developer, and yes, we have the characteristic of having a big composite hull that we have identified as being the most structurally efficient to extract energy from the waves. Of course, that comes with lots of challenges. Because of course composites can be affected by the water environment and also by lots of fatigue cycles. We're talking about millions of cycles, and this in combination with the water degradation that can bring some challenges in the optimization of the structure. So I think that is really the main challenge, is this combination of many cycles plus water environment. A secondary challenge is also to scale up. We have a lot of demands now, and we need to scale up our processes in these traditional manufacturing processes of composites. So we're looking at industrialization and manufacturing processes that is key to our success. And doing so in a sustainable way is of course of very big importance for us.
And how, if I may ask, how many units do you see out there in the oceans in the future? Is it going to be 500, 1,000, 2,000? I mean, get the perspective of how much material and composite that will be out there in the future.
Yeah, it all depends on the market demand, but at the moment we see a very rising demand of decarbonized electricity. So we don't really have limits of numbers at the moment. The resource is really large and widespread over all continents. So there could be, yes, we could talk about thousands of devices, of course. Or more.
Yeah, and how do you see? What needs do you see in front of you in terms of validation of your materials? It's not only this site. We will come to the collaboration site later on session. But what are your needs, and what do you need to validate for your future devices?
Yes, I think that's answering this mixed situation that I was talking before. Is we need to validate the materials in their fatigue performance and also in their water performance. So beyond the typical tests that we usually carry out in composites to evaluate their strength, we also need to test combined loadings, and I think that's where it really makes sense to have skills like you are developing now at RISE and testing capacity to validate different materials. Beyond that, I think also having resources to evaluate their sustainability of different options is good to bring that to the industry.
Yeah. And on the test site here today, you have a few different testing, right? Is there any particular test you would like to mention, or any projects that is ongoing that you want to mention?
Yes, we have the wet hull project between CoPower, RISE, and a few other players. So it's really interesting. We are testing some panels with different anti-fouling coatings. We're also testing strength in the lab, and we will soon test some cleaning strategies on composite hulls with probably some automated devices. So that will be really exciting.
Okay, thank you, Antoine. Is there anything you would like to pass on to Christian to bring that Christian will take with him for future testing at this site, for example, that he needs to be aware of for your technology or requirements?
I think it's a bit of all that. I think we need to keep a very close collaboration between our different organizations, work together, defining the different projects, and include all those aspects in each project. So I think it's really the multidisciplinary approach that is key to us for the success of those technologies.
And Christian, what do you see for the future regarding testing on composites in, let's say, 2050? where we'll be in the composite situation? Will we have algae substituting any substrate in the composite, or how do you see it?
No, I'm actually thinking you're quite on the right path there. I think we will use a lot more natural resources inside the composites in the future, 2050, and I think we will have come much further in recycling and also we will find a circular way to use the composites in the future, and by using bio-based materials, for example.
Thank you, Christian. And one last question to Antoine. Do you have any sustainability strategies incorporated in RISE? No, at Core Power. Sorry.
Yeah, we are also new to that. We are developing slowly our strategies. One good thing for us is that optimizing the performance of our structures is basically creating more clean electricity with less material. So optimizing the structure, etc., is already a good step towards sustainability. But of course, it goes beyond that, and we need to evaluate all the choices of materials and all our operations. So there's still a lot of work, and for now we have chosen standard material combinations that are well proven for our first devices, but we are already looking in the future at refining those choices and making sure that we design the devices from the beginning with a life cycle perspective. So also looking at end of life and making it ready to enter this circular economy. So there is a lot of work to be done there, but we are well determined to be working on that and to be at the forefront of this.
Thank you, Antoine. It was very insightful. I hope you're the best in the future. I hope you will see a lot of ocean energy devices out there creating renewable energy for us. And thank you, Christian, for insightful from RISE perspective and how we can support the companies on their journey. Next session will be on marine wood. And I would like to invite Mats Westin, who is a senior scientist for durable wood at RISE, to say a few words. As you're aware, we are having difficulties with connecting to the test site. So Mats will be online. I hope we can fix the IT problems for the next session. I also would like to invite Stig Lande, R&D manager at Kebony Wood, for this session. But I will hand over to Mats Westin for a few questions first. Mats, are you online?
I think so. Can you hear me?
Yeah,
yep.
I can hear you.
Fine.
I can hear you fine. So, Mats, tell me a little bit about the testing at Kristineberg. You've been there for a while, haven't you?
Yes, I mean, we are testing wood materials, treated wood and bio-based composites for resistance against marine wood borers, like chickworms and gribbles. And these creatures are the worst wood-destroying organisms on Earth. So they can destroy wood in a couple of months. Typically, in just half a year, we have lost 90% of the wood volume for our test specimens due to shipworm attack. And behind me, I put up some photographs from our testing. We put out wood samples on ladder-like rigs, put them on the bottom of the sea, kept upright by a buoy. And then we bring them up at least once a year, clean the samples, and then we X-ray them. And behind me, you can see the X-rays, what it looks like when it's attacked. And if you cut one open, it's completely destroyed if it's an untreated wood. And we have also this same kind of testing in Portsmouth in England, in Olhão in Portugal, and in Venice in Italy. But mainly we're testing at Kristineberg. We started some 30 years ago, actually. And then since 22 years, we are the only one accredited for testing against this in the Nordic countries. I would say that our main interest is to develop materials that can withstand these attacks. And so chemically modified wood, new types of wood preservatives, and also composites that would work in these conditions.
Thank you very much, Mats.
I should add that now, from now on, we can hang rigs from the floating dock, which would be an advantage because it costs a lot to bring a boat with a crew to bring the rigs up every year.
Yes, but that was a regulatory demand before, wasn't it?
Yes, but I'm also in the standardization committee. I'm trying to change it. So from the next version of the standard, it will be allowed to hang them from the dock. So.
Thank you, Mats.
Yes.
I would like to introduce Dr. Stig Lande, R&D Manager at Kebony Wood. Stig,
Yes.
Can you hear me?
Perfectly.
I hope we can get you broadcasted as well. There you go.
Hello.
Stig, and you're R&D Manager at Kebony Wood. Tell us a little bit of how you've been here at Kristineberg and been testing for quite some time, as I'm aware of. And what is it that you are testing, and what do you need to validate in your test?
The technology, I have to just say that Kebony is dealing with modified wood, chemically modified wood. So this is a new type of wood protection, probably not new anymore. We have been doing this starting for 20 years ago. I guess the very first start of the company started in 1997. And then quite soon we made contact with SP at that time and RISE now for looking into a technology based on sulfur alcohol, which is a renewable chemical. So I would say the technology we are producing today have been researched in the marine field since 1999. And we started with our production
Okay, it seems like we have a communication issue to Norway. Let's see if we can get Stig Lande back online. Stig, can you hear me? Let's see if we can get him back.
Otherwise, I could comment on that.
So, Mats, what would you say has meant in terms of improvement of Kebony products since you've been quite involved in this test?
Yeah, we have been involved in the development of their products and testing of all the different process alternatives that we have been looking into. And some of them works excellent. So we have had samples out for now almost 20 years without any sign of attack, which is far better than all the best of the preservative treated woods. So
I guess I'm back in the online session.
Thank you, Stig. I think this is a part of the situation we are in Europe today with the IT problems. I was just asking Mats what Kebony had been testing, what it means in terms of improvements of your products. How have you accelerated?
It's not only an improvement of the products, because today, and we have never actually produced material for being marine applications, but we explore the technology in depth. So by having this test field, we have learned and we have increased our knowledge about a new way of protecting wood. And we have been actively having.
Now you're muted, Stig. I think, Stig, you are muted. There you go.
Sorry. Seems like it unmuted by an accident. I don't know. And then, well, I say that it's not only an improvement of products, it's an improvement of knowledge. By having skilled researchers with the tools to evaluate new technology, increase, of course, the knowledge about new ways of finding good products. And as Mats said, there are examples of this technology resistant for marine applications. And we have been researching this in collaboration with other universities as well. So we have then built up an excellent center, more or less, with our network. And without having this would not have been possible. So I would thank especially Mats Westin for being so dedicated to keep this alive. And I guess for the future, it's essential for being able to utilize renewable materials, not only wood, but bio-based materials. So there's no doubt this starting and focus on also including a very active and good test site will give us opportunities for the future. No doubt about it.
Thank you
yeah.
Thank you very much, Stig. This is a very interesting subject, the marine wood. I can see it coming into many different areas. I can see wood towers for windmills, and they are going offshore and things like that. So it's a very interesting area, and I look forward to what the future brings on these materials and how that can develop the marine structures. So I would like to thank you for today, and we'll move on to the next session, which is the concrete session. And I would like to welcome John, and he's from RISE. He's a senior researcher, and he, I think we have a connection to the test site at the moment. So I will leave it to Simon on the test site to interview John, and let's see if we can get them online. Jan, can you hear me? Yeah.
Okay, so we're back here at the test site. We'll see if we get some luck with all the technical stuff now. I'm here with John, and I would like to ask you, what are the challenges for concrete in marine environment exposed structures? And could you mention some projects at RISE that address these challenges?
Yes, thank you for that question. Of course, nowadays the first challenge is sustainability for our structures, but we understand it in many different ways, or we work with it in different ways. First of all, we work with infrastructure objects, so like bridges, harbor piers, and offshore structures, and we try to extend the service life of those structures. Concrete is a great candidate material for this, as it has a very good performance to price ratio, better than steel and composite still. Yeah, we try to introduce as much as concrete as possible in those structures due to this high durability and good performance. We're having a project on making a competitive concrete foundation for tidal turbines for tidal energy, and from LCA and of the developed materials and structure, it comes out that it's competitive both in sense of environmental impact and costs, comparing to steel foundation, which was the state of the art before. Of course, the durability is a big challenge, and there we are working with new mixes of concrete which are better protecting steel from corrosion. We had a project, EU project Rossini's, where we developed mixes resistant to very harsh environments like Arctic offshore structures. And there we were also testing in real maritime environment here in Sweden. Of course, we are looking also into innovative materials, new material solutions like non-ferrous incorrosive reinforcement made of carbon or glass. We are also looking into lightweight and thin-walled structures from high-performance concretes. And we are looking into circularity aspects, of course. So crushing down concrete and using it as an aggregate in a new material. And these are some of the objectives of the VECHL project about materials, sustainable materials for wave energy.
But we have heard that about the high CO2 footprint from concrete. Is it a good idea to keep using it if it has such a huge environmental impact?
Of course, cement production is contributing a lot with the CO2 footprint, but the best solution is not to stop using concrete, but to make it more sustainable, change it, develop it, enhance it. So we are doing this with replacing partially cement with supplementary cementitious materials, which are usually waste materials from other industries like slag or bioashes or silica fume and so on. And at the moment, we are replacing it by 30–40%. But with our projects, we want to push it even further, up to 80–85%. And then we decrease the amount of cement and decrease the CO2 footprint, basically. And we make concrete still a good material, durable, inexpensive, and more environmental friendly, or we decrease it environmental impact.
And these samples we can see behind you, what are you testing?
Yeah, these samples are panels from the VECHL project, actually, that I mentioned before, and they perfectly summarize everything I've just said, because this is an ultra-high performance concrete, so it has five times higher strength than a normal one. It has it's reinforced with a carbon textile reinforcement, so it's non-corrosive, and it also has a very high replacement level, so it's more than 80%. It's replaced mainly by slag, but also others. And here we are testing, the application is to build a thin-walled floater for wave energy with only thickness of 30 millimeters. But in this test, we are mainly focusing on biofouling. So we want to check if algae will grow more on this new sustainable green concrete than on the reference one. So these are ready for testing soon. And down there, we have already reference material that is being tested already for 2 months.
Thank you so much, Jan. And I think we go back to the studio to Pierre.
Thank you, Jan, and thank you, Simon, on the test site. I would like to, for this session, I also would like to introduce you to Annika Oskarsson. She's head of asset manager for marine structure at the Port of Gothenburg. I also want to introduce Mikael Sidemark, who's the CEO of Ocean Harvesting, producing ocean energy technologies. Welcome. I will start with you, Annika.
Yeah.
Could you describe your infrastructure a bit so we understand a little bit what an asset management and marine structure for Port of Gothenburg includes? Because I think it's rather big, isn't it?
Yeah, it is big. That's correct. Thank you for being here. The Port of Gothenburg is an old port. You know, it's 400 years, and we try to be here for 400 more years. And in that way of thinking, we have to be sustainability, and we have to focus on durability. So we have concrete quays and concrete piers, and the most common structure we have are concrete slab on concrete piles. So that's a lot of concrete, and I think we have altogether some 11,000 concrete piles built in the 1950s to the 1990s. So one perspective is the old structure and how to work with them, and at the same time we're building new terminals and new quays, and then we have to have focus on new materials. So, and we have been working with this asset management program and inspection program about 15 years. So we think we have a good knowledge of the condition of structure, but now we have to focus on new materials and how to keep them for as long time as possible.
Yeah, what is the main challenge for you at this very moment? Is it to maintain them, or is it to get new materials to be validated? Well, in the speed you need them, so to speak.
Yeah, I think it's the both of those two questions, because the most important is to know your structure. And as I said, we have been doing all these investigations and inspection for a long time and studied the deterioration process and deterioration for concrete and then corrosion for rebars. And the challenge is to combine those two processes for asset management. So that's for old structure, but in new structure, as we said in the earlier part of this program, is the new materials and renewable materials in concrete. How could we use concrete for new piles and so on with more friendly materials or even reused materials?
Yes, and what if I may ask? I asked this question. It's a tough question to. It shouldn't be a tough question, but sometimes it is. Do you have sustainability strategies for these in place in Port of Gothenburg today? So you're working towards something.
We have in our business plan, we have this goal to aim to reduce CO2 footprint. In that part of our work, we work with the activity to work with steel and concrete. Yeah. And in new structure, we work in one project, this Port of Scandinavia, when we're deepening the fairway, we're looking into using less concrete in the design phase. That's the one way. But we will also looking into research innovation for the producing phase. Yeah. Which company could produce concrete with less carbon footprint?
Is there any takeaways for Jan that you have on top of your head from these conversations, or do you want to challenge Jan as a researcher a bit?
Yes, I would like to do that. Thank you. I think for structure, the lightweight concrete and using less material, I think it's interesting to combine that with the engineers, design engineers, and go from research to guidelines for our design engineers. I think that's the most important, because you have to take the research result and make it to work for the industry. And I think that's a part to speed up that process.
Yeah. Any comments to that? I'll give you a 1 second comment, Jan, and then.
Yeah, of course. I mean, yes, I agree, completely agree. And this is what we are trying to do in the VECHAL project. So we are looking in existing standards, but we are also trying to push it forward and present on this test case of a floater that it's possible to go down with the thickness, to use new types of reinforcement, new concrete mixes. But of course, this is an ongoing process, and we collaborate also internationally to achieve this, to introduce European standards for FRP reinforced structures and so on.
Thank you, Jan. I will let Michael from Ocean Harvesting come into this discussion. You're developing an ocean energy device, and having Port of Gothenburg and an ocean energy device in the same call, your common ground here is concrete. Can you explain why concrete is so essential for your development in your device?
Yes, thank you, Pierre. I can mention that we have been working originally with a steel hull construction, and in the last design update we actually separated the floater from the PTO system and made the floater in a cylindrical, wider 12-meter diameter. And it turned out that making this shape that we need to get good, it is a design we had chosen for the performance reason. It became very expensive to make this in steel. And part of that reason is because it has to be submerged through large waves. It becomes a pressure vessel, and these changing pressures puts a lot of stress on the structure.
Yeah.
So we have been looking at different types of materials or alternatives, and found that concrete hull is a very interesting way of making a floater. And a part of this is that we can replace the air with the polyurethane cores, and that removes this pressure vessel requirements and simplifies the structure. This makes essentially the whole buoy a lot cheaper. So at least a third of the cost is what we expect from this. It does become a little bit heavier, but we don't see negative impact on the performance at all from this, partly due to the wide diameter. So it looks really, really promising, and also in the manufacturing, that it can be manufactured on site. That simplifies logistics and transportation a lot.
Yeah, I was meaning to ask you about that. How on earth do you manufacture and transport it? It's supposed to be 12 meters in diameter and weigh a bit over 100 tons. Is that correct?
Yes. I think many floaters for wave energy become quite large when you look at the full-scale devices. So the strategy we have is that the PTO system can be transported with road transports in containers. The floater could not be manufactured somewhere and transported because of the large size and weight that you mentioned. But a big advantage with having a concrete structure is that it can be molded on site, on the dock site. So it's cement trucks sent to the installation site, or the dock side to the installation site, just like a common construction work. And these EPS cores we are using as void fillers can be packed up in a truck and transported easily. So I think this is a huge advantage with these concrete floater, that it can be manufactured easily with a molding process on site.
Thank you, Michael. This is quite interesting. We have a port and we have ocean energy technology, and they share common goals to minimize impact on the footprints or in the oceans. They want to be light. They want new materials for the future, etc. So this is a quite challenging, I would say. John, how do we get there in? Well, it's not many years left to 2030. I'm trying to fulfill the UN decade sustainability goals. Will we get there?
We are doing what we can to achieve this, and I would say like research is really pointing good directions, which I have already mentioned. So replacing of cement with other binding materials, which are wastes. So utilizing wastes, going into circularity. So reusing the concrete that we design now in the future for a new one, and also higher durability, longer service life. And this can be obtained also by new material solutions. So that's why I think this research site in Kristineberg is so important, because we will mainly focus here on durability and these aspects and test them, present them, and we hope that this will change also the market and the approach of construction companies. They will believe that it's possible by using this new materials and using this higher replacement levels to really change the concrete industry, basically.
Thanks, thank you, Jan. And thank you, Annika and Mikael, for joining us in this opening of the test site. I hope to see you guys very shortly on site with your products, and I'll see you in the future. Thank you very much. We'll now move on to the next session. And that is the session for corrosion. And I think we have Simon on the test site with Johan B. Lindén, who is a senior researcher at RISE. And let's see if they have, I think they are ready now to go live. I'll hand over to Simon.
Okay, so Johan, why do we need corrosion testing in marine environments? What are the benefits compared to simply using salt in the lab?
Use sodium chloride or artificial seawater lab to check some. Natural seawater where you can have which means that micro and macrofiber can influence corrosion processes. So this is what we want to be in the natural environment. Okay. Sorry. So we really believe that it's important to test in natural marine environments to be closer to the field. And here we can do both. We can test outdoor and we can also test indoors as well.
And what kind of corrosion tests can you offer at the test site?
We can offer different kind of atmospheric corrosion tests where it doesn't have contact with the seawater. We also do splash in the splash zone closer to the waterline as well. And we can do submerged testing as well. Under the jetty, it's down to 6 meters.
Try to do like this instead and see.
Okay. Yeah. So I mean, we can be submerged down to 6 meters. And at the Gullman fjord, we can go down to 100 meters, quite close to here.
So how can you compare or calibrate with other test sites?
One thing in atmospheric corrosion testing, we have reference coupons of pure metals, carbon steel, zinc, aluminum, copper, and we measure the mass losses of those pure metals annually. And that we can compare to other test sites in Europe. Here we also have other stainless steel or aluminum alloys that we look at more localized corrosion attacks. And we also measure other parameters like wind, rain, downfall, temperature, relative humidity that is affecting the atmospheric corrosion processes as well. And in the water, we are measuring salinity and dissolved oxygen and pH and, to make sure that we can calibrate.
And what are the benefits for this new test site?
I would say it's the accessibility. We have electricity, water, compressed air at the jetty. It's docked onto a great research station with great facilities, accommodation, food. You can stay here. And the indoor lab is 10 meters from where we stand right now. So you can go and prepare the samples and examine them and do other indoor lab tests if you want. So I would say that's the main benefit.
Yeah, that sounds wonderful. So I think we'll go back to Pierre now. Thank you so much, Johan.
Thank you very much, Simon, and thank you very much, Johan. Meanwhile, Johan is making his way to the studio. I would like to welcome Victor Reftegård. He's a corrosion and treatment specialist at Volvo Penta. And could you explain a little bit about your business at Volvo Penta and why this is issues that you need to tackle?
Okay. Yes. First of all, thank you for inviting me to this inauguration day at Kristineberg. At Volvo Penta, we are a manufacturer and developer of let's say power solution, both for industrial applications and marine. And I would say it's a 50-50 split there. And Kristineberg typically would be a very good way for us to do complementary testing in the marine, on the marine side, of course. And we have at our test center where we in the past have tested mainly boat applications. We also have some corrosion tests today. We have the possibility to do immersion testing, what we call fly bridge testing, which is typically what you saw at the place where Johan was standing just before. We do some fouling tests, climatic chamber, but I mean, it's myself working with corrosion and surface treatment. We have one colleague working part-time with corrosion testing, and we have a paint expert, and that's it. So as you can understand, it's a very small group and we have limited resources. So I see Kristineberg as a very, very good and close collaboration partner when it comes to do all these kind of testing.
Thanks, Victor. And I would like to ask you, I mean, an international or a European network that also, I mean, you're an international business, right? So I would say that the ocean has different criteria in different places. I mean, down in Venice in Italy, it grows like, yeah, it grows a lot. And it grows differently here and it grows differently in UK and so forth. And how is that network important for you guys at Volvo?
Yes, as you say, our customers and our dealers are distributed all over the world. We need to do tests in different environments, of course. We have a collaboration since a few years back with your site in Brest, where we are involved in the MRC7 marine corrosion program. We also have a marine test center in Suffolk, Virginia, but they are more focused on boats. They can do some simple tests when it comes to fouling and corrosion, but not very much more than that. And we also have a collaboration with an institute in Florida. But I would say Kristineberg, even though it's quite close to Gothenburg, our water quality differs significantly. I mean, in Gothenburg, we have our test center at the river mouth, so we get more brackish conditions. We have a lot of marine growth there as well, but it's different from what you would see up in Kristineberg, which we have experienced since in the past as well. I mean, we were present in Kristineberg during the early 2000s and had our immersion testing up there in the past before we moved it to our test facilities. But I see it as a very good complementary testing, and also during intensive test periods, both when it comes to let's say corrosion testing, if it's immersion or marine atmosphere, but also when it comes to fouling. If we have intensive test periods, as I said, we are a small group working with corrosion, so we would need for broader testing. I think Kristineberg is a very good option for us.
Then I have a very difficult question for you guys. I think I'm going to pass this to you, Johan, and it's also for you to answer, Victor. I know corrosion has been it's a known problem in the marine environment. Shouldn't it be been solved by now, or will it ever be solved? It's a very difficult question, I know. I need to ask it.
Yeah, well, I mean, as you say, corrosion has been around for a very long time, and they studied marine corrosion also for a very long time. I know in the States they've done a lot of tests with, I mean, any possible alloy. But the thing is, when we
I mean, the marine environments are probably one of the harshest for metals, alloys, and you can't really. You have to create really smart engineering products, vessels, ballast tanks, pipelines, any kind of thing that needs to be in a marine environment. You need to think about all the possible scenarios for deterioration, degradation. You have biofouling coming in that can influence corrosion. Microbial induced or influenced corrosion is a really tricky problem to attack. So it still is a very complex question, and it's sometimes it's not a very hot topic to put a lot of money into, because I don't know, it's sort of neglected sometimes, I think, but it's still very important. I don't know what you say, Victor.
Yeah, well, I agree with you. I mean, it's not always a hot topic to spend a lot of money on, but still you keep spending a lot of money on corrosion if you don't focus on it to begin with. And of course, we could solve corrosion for our products if we used very exotic and expensive materials, perhaps like titanium alloys and so on, but you always have cost in the picture as well. And also what we see in our business at the moment is that the way of handling boats is rapidly changing. A lot of boats tend to spend more time in air than in water. When they are in water, they are cathodically protected, but more and more customers, they pull the boat out of the water after each time they use them, especially in the US. And there we start to see issues with, let's say, galvanic corrosion, for example, since we use a lot of stainless fasteners. So we are starting up a project to really address those questions as we speak. And for that, we need to change our way of doing corrosion tests. So we have before COVID, we started to work together with the Johan and Johan's group on finding better ways of doing these, let's say, marine atmospheric corrosion tests that correlate with our fields. We have supplied them with test material, and we will share experience as we go along this road. So I have high hopes in getting a much better test cycle, since in the past, Volvo Penta is a very small player in the entire Volvo group. So we have had to rely on the automotive test cycles more or less.
Thank you, Victor. Thank you, Victor. And it's, I mean, it's also what I understand. I mean, you're developing the technology, Victor, but then you would be relying quite heavily on strategic collaboration with coating developers and other companies across the globe, I would say, internationally.
Yeah, very much so. And a lot of, let's say, our suppliers they have their sub-suppliers, which would be the coaters, and usually the kind of coatings that we have to rely on, all the tests have been done either for the automotive business, but also on different materials than we use. Usually the tests have been done on extrusions or sheet metal, which is low alloyed material, which has quite good corrosion characteristics. But we use a lot of cast materials as well, and the let's say pre-treatment processes have not really been tested on those. They have been developed for other alloys, and there we have had a big challenge throughout the years, and had to work in very close contact with the suppliers of the chemistries to really tune those processes to be adapted for our materials and environments as well.
Yeah, and I was coming to that, because then you will be, then Volvo Penta is the company who puts the requirements onto the sub-suppliers and form the strategies to become sustainable for the future on those products. So you're the guys who needs to put some pressure on those developing these coatings and etc.
Yes, for sure. I mean, when I joined Volvo Penta in 2012, I think it was, we actually, my really first big assignment was to phase out Chrome 6, for example, which we started. I know they've done trials 10 years before that as well, without really succeeding, but that was my really first big project I worked in, and to do that before actually the legislation hit us. And I mean, a lot of our production is in the US, where it is still acceptable to use hexavalent chromium, but we want to be ahead of that and really phase it out globally.
Yeah, and for some last well, do you have anything for Johan to take with him when it comes to focus on further developing on these test sites that you see from your perspective?
But I think the work I've seen being developed is very interesting, and I hope that now that we see an end, or at least a fade out of the COVID situation, I hope we will be able to work more intensively together again and share results and experiences and make good progress when it comes to the corrosion tests.
Thank you. Thank you very much, Victor and Johan, for giving us an insight on the challenges and your needs for future and to become sustainable in these ways. We'll now move on to another area, which is a massive challenge for in the marine environment, and it's the biofouling area. And in this session, I would like to introduce Dr. Emiliano Pinori. He will be on the test site. And in the session, we will also have Don Isaacson, Research and Development Manager from ITEC, Simone Garufoli, Technology Innovation Research Group at Buero from Italy, and Christian Andersson, Material Specialist at NKT. We'll see if we can join in on the test site first and see if Simon is ready down there. I think they are. So let's see if we can go over and have a discussion with Emiliano and see if it grows anything in the ocean up here in the Nordic countries.
Okay, so Emiliano, could you tell us about the research projects that you have going on here?
Yes, we have many different kind of projects. As an institute, we work both with research projects, but also with the industrial project and some kind of validation. So we can see actually that we work with past, present, and future anti-fouling. When I say past, I mean that recently, for example, we did a study for the amendment of the guidelines for the fouling globally for the European Maritime Safety Agency. It will be published soon on their website because they are introducing the control of another active ingredients, that is Hilgarol, and so we help them with that. When I say the present, I mean the industrial registration of new products. So the anti-fouling process needs to be registered with a special regulation framework. And we do here the efficacy test, and back in the lab, we do other kind of tests that the industry needs to register. For the future, I mean, both that we are in research projects like WECUL, Sea Snake, the RISE, these are all names of projects that we do for the renewable energy, wave and tidal. But also the future, because the samples are coming right now. We are just way stressed to receive everything and start testing for this season together with a lot of people in this inauguration. And so that is what we do. And especially I'm stressed for the logistic and for the all these industrial testing with us. Also with industry, we do some future activities, product development. So it's not public funded, it's private funded. And many of these are here, but I cannot show you.
But why do we need to test biofouling?
biofouling actually, it's a natural phenomenon. It's also good for nature. You can imagine that, I mean, ocean is a living organism, and when you put something in the ocean, all these organisms, sessile organisms, like the one here, they will race for the surface. They need to colonize any surface. So this is very good, but it's bad for blue growth and all the other human activities. So man-made material, engineered material, they cannot be efficaciously doing their job or having their lifetime if all this stuff grows in it. In some cases, it's because of the drag force. In some cases, it's because of the weight gain or the accelerated corrosion. So then we need to take care of the surface in order to protect from fouling. But the problem is that usually, I mean, fouling has been a problem since the human has started to use the ocean. And the stuff that they put in the paint was really bad. Even recently, the problem was solved with something we call the organotin compounds. And this has been done globally at the beginning of the 2000. Because so all these kind of active ingredients, they go out and they also do an impact to non-target organisms. So why we need to test? Yeah, because we need to address the problem in a more sustainable way. So what we do here is to try to tailor the solution to different problematic to reduce the use of active ingredients, so just not use it. So we do some kind of try to make this regulation and the future of the ocean more sustainable by validate what is the new anti-fouling strategies.
And why test biofouling at this particular test site?
Yes, fortunately, we still have some biodiversity in the ocean. So different sites in different geographical areas in Europe and the world, they have different fouling pressures, specifically different organisms. As you can see here, in the north of Europe, we have a lot of hard fouling, so barnacles, tube worm. So here it's very high the pressure for these organisms. That especially barnacles, it's so because it's everywhere in the ocean, and it's one of the strategies people working against fouling. It's very difficult. So here it's but of course, market the product that is also under regulation. You need to be sure that this product will work everywhere. So what we do together with our friends and partners all over Europe is to parallel testing the same stuff in different places. So you can understand about this. Thank you very much.
Thank you so much, Emiliano. That is it for us during test site. And back to you, Pierre.
Thank you very much, Simon, and thank you very much, Emiliano. And while he makes his way to the studio, I would like to introduce Dan and Simona and Christian. Dan, you're working with biocides for different applications, and Simone, you're working with the paint that goes on different application. And Christian, you are actually a developer of cables and one of the third biggest cables manufacturers in Europe, I believe. So when it comes to biofouling, this has been a known problem as the corrosion as well. But if we take you, Dan, we discussed the Selektope that you have a substance which is a biocide. These are quite challenging areas to work with within the in Europe and prevent these ones. How long does it take to get a biocide through a biocide directive, for example?
Yeah, we started our work with the registration dossier back in 2006, and then we could submit that in 2009. And it got approved by 2016. So that was about 10 years of work to just get the biocide approved. So yeah, it's an extensive work to get somewhere in Europe. And then you have all these different regulatory areas around the world with different demands. So it's a challenge, yes.
And once you've had the biocide approved, then you actually have to have the biocide approved for different applications. Is that correct? Or different materials as well? So, and what would you say it takes to get to the market with the product in the end?
Yeah, correctly. I mean, first all the biocides need to be approved, and then all the paint producer or whoever would like to use the biocide need to have their products approved as well. So depending on the process and where in the world, but let's say in Europe, if you can be fairly quick of developing a product that is ready for market, that would maybe take, I would say, 3 to 5 years, depending on how they do things. Maybe shorter if the product is an already existing product where you just add Selektope on top of that. But if you're to formulate something new or use new materials, then it's definitely a longer process, maybe even longer than 5 years. And of course, on top of that, you have a regulatory process that can, yeah, you never really know how long that will take, but at least 1 to 2 years, I would say, at minimum.
So what would you say a normal test campaign would be like? Is that 1 to 2 years or 3 to 4 years, or?
It depends on the application. If you're looking at commercial paints for ships, then you probably have, first you have 1 or 2 years where you're sort of screening, and then you can make test batches that will go on ships for a couple of years. And then when you're done with that, you will probably do a few full applications on ships before you release any sort of product. So it can easily be 5, 6, 7 years before you have a final paint product.
Yeah. And this biocide that you have, that goes into different paint. And Simona, you have a paint from Buero. If I-Tech would like to test with you guys, what are the different scenarios that what is required from you for different scenarios that you would test to have it approved, so to say?
Yes, first of all, thanks to invite me. Inside Europe, there are many expositive scenarios, very different between each others. For example, Mediterranean environment is totally different from Swedish one. From that perspective, we think that it's very important to test our products in the same scenario or as much similar as possible to the market where we want to have the business. I think that just to resume, everything is connected to our mission. Buero mission is to test and develop products as much sustainable as possible.
Yeah, and so we're having biocide from I-Tech coming to the paint, and the paint needs to be certified in some different ways and different testing. And then we go down to Christian, that is having an application that needs a paint. And Christian, you also needs to certify your so it works with your application, so to speak. So it's a quite long process to get this product out there on the market, Christian.
Yeah, I mean, we normally make anything from low voltage to medium voltage and building wire cables. This is more or less a new segment for us. We developed new cables, which we call dynamic and semi-dynamic cables. It's for the marine power segment, so covering tidal power and fish farms and electrification of ships and such. So it's been a pretty long process developing that. That took a few years. And we've been in one research project before with you, and now we're in a second one. And this time around, we come to a work package where we actually look at the anti-fouling on our cables, which is, I mean, if not the most important, but it's still an important factor for the longevity of our cables in the ocean.
And I mean, all your products needs to be sustainable once they're in the water. So what would you say, Christian? I mean, then you need to work very closely in collaboration with, for example, Buero and I-Tech in order to get to a sustainable product in the end. And Emiliano, who's helping out with the test. do you have a sustainability strategy in place for NKT that is actually promoting those collaborations or actions that you need to take?
Yeah, we have collaborations, but not with the people you mentioned. I mean, we're doing it. We are having an internal process, and then we're mainly working with our big current customers, which would be Swedish utilities like Vattenfall and Levio and such. And then we also work with the material suppliers. So because of dynamic cables being a new segment, we're not all the way there yet. But I mean, in our normal cables, I'm happy to say that we just a few weeks ago closed the loop on our last problematic material from production. So we theoretically can now take care of all materials from our production at least. And it's my aim to do the same thing with dynamic cables. I mean, now we're trying to put them to use. So working with sustainability on that I will spend the next coming years to solve that for these cables as well.
Yeah, thumbs up for that. Simone, what do you see as? I mean, you have a lot of testing requirements. So I would assume you have things that you would ask Emiliano to fulfill when it comes to testing at a site like this. Is there any particular things you want to pass on to Emiliano in this discussion?
But obviously, it's important the rough test, so to know the efficacy of the paint. But it's also important in an equal way to know the behavior of the paint. So, for example, it could be very interesting to test the efficacy of the paint and in parallel the release of the paint, and more in deep, if I change the release of the paint, what could happen in the field. It's very important to have this kind of connection, this kind of combination. And this for every scenario, because the release is connected to the type of seawater.
Yeah. Emiliano, as a researcher, I mean, you're quite challenged with these. I mean, both the strategic position that EU has, and then the companies strive for business. And how do we get this together in the end? And do you see a way forward to meet those goals that we have in the future?
Yes. Hi. Actually, this is what me like the most. Working in an institute is not only focusing on research or basic research, but also knowing all along these years together with Simone, another customer, together with Dan. I mean, we get to learn us all the way to the market, from the low TRL to the launching on the market. So what Simone was saying is exactly what we do together with them and others, that we do the test, we try innovation, then we go out and do this test that is needed for the regulation. We go back to the lab and see the impact on the environment. So putting all this together means that you can try to make some innovation, but at the same time you talk with the value chain, so that this kind of innovation that are lower impact to the environment actually comes to use, because then when you change the impact on the environment is when the market accepts a more environmental friendly alternatives, rather than just, I mean, I like also basic research, I'm not talking about that, but we like also to make difference through the market.
Thank you, Emiliano. And I would like to thank Don and Simone and Christian very much for participating in this discussion. I look forward to hear more about this in the future, and look forward to welcome you when we finally get to travel a little bit more. So thank you very much, and I would like to thank every researcher and every company that has been part of this session. We had some hiccups in the IT on the test site, but we managed to solve that somehow. Great team we have working on it, and I would like to move on to how do we get together and work together, and how do we collaborate on these challenging subjects that we've already discussed in the previous session. So I would like to welcome some of the test sites in Europe that is doing material testing and are some of the most promoting, most advanced ones, I would say, and that we do collaborate with today. I would like to welcome Anna Brito Emelo, who is a senior advisor at WAVEC. I would like to introduce also Pablo Banguira, specialist materials for extreme condition and their harsh lab. I would also like to introduce Nicolas Larcher, Institut de la Corrosion. And he's responsible for the marine corrosion. And also down in Plocan at Canary Island, Jose Joaquin Hernandez Brito at Plocan. He's the CEO at that place. And so welcome. Why is collaboration so important when it comes to validation of marine materials? I would like to pass that on to Anna. That question. I'll start there, I think.
Hello.
Hello, Portugal. How are you doing?
I'm fine, thank you.
Maybe before we go to that question, you can say just a little bit about WAVEC. Sorry about that. So just
yeah, WAVEC is a research-based institution. It's a non-profit association, and our main activities are on marine renewable energies. So we have a multidisciplinary team working in different activities. So on the economics, on environmental impacts, on materials, on numerical modeling. So looking to all aspects related with the development of ocean energy technologies. We are a team of 25 people.
And we are collaborating today, aren't we? A little bit on different.
We are collaborating. I mean, we have a good historic of collaboration between the WAVEC and RISE and other Swedish organizations.
We were actually hoping to show that we have two actually test rigs, one in Portugal and one in Sweden. So we're doing tests in both sites.
Yes, that's a very interesting collaboration indeed that we have now in the scope of the RISC project. I think it's a pity that we cannot show what we are doing now in this project, but it's a very interesting collaboration, as we had very recently also within the Oceanic project also.
Yes, correct.
All related with the materials and extending the lifetime of materials. So interesting topic.
Yes. I would like to go to Pablo at Harsh Lab. I can see your picture in the back. It's a massive device you have there, and it's quite far out in the ocean, isn't it?
Yeah, absolutely.
A little bit about that.
Yeah, well, Harsh Lab is an offshore laboratory for materials that is operated by Technalia. It's the research center where I work. It has about 5 meters diameter and 5 meters height. It has 3 zones of exposition, immersion, splash, and atmospheric. And we can test more than 700 samples at the same time here. We've been operating it since 2018. And well, I think that is a pretty good version or pretty good infrastructure for testing. It's about 2 kilometers away from the coast in the Gulf of Biscay in the north of Spain. So it's really 100% offshore conditions while being relatively accessible by 10 minutes drive by boat. So I think it's a very good opportunity for testing materials in real conditions.
Yeah, thank you, Pablo. I'll leave the word a little bit to Nicolas. I heard Volvo Penta mentioned on the corrosion side. So please tell us a little bit about the Institut de la Corrosion in Brest in France. What are you up to down there?
Yes, hello Pierre, good morning to all of you.
Good morning.
So actually I work in Brest, France, the French Corrosion Institute, which is the French branch of RISE. So we have a very tight collaboration with the marine station of Kristineberg, for instance. So in Brest, we have a large-scale marine station where we are able to test from full-scale to small-scale samples. And we can test a lot of coupons at the same times. And we also have a lot of collaborations with different marine stations in the world so that we can understand the differences between all these marine stations.
Yeah, thank you, Nicolas. And then Jose, down at Canary Island, you have one of the, I would say, one massive test and demonstration site for numerous different technologies, and among those marine materials as well. Please explain a little bit where you are and what activities you have.
Good morning. Thank you very much for inviting us to share with you this inauguration. So in Plukan, we have a test site of 23 kilometers. We are testing there all kind of technologies from offshore devices or things related with marine renewables, but also we are testing structures, also concrete corrosion, and also we are interested in everything related with observation or testing devices for censoring the ocean.
Thanks. Thank you very much, Jose. Back to my question then that I asked before. I'll pass it to you, Anna, again. So why is European collaboration so important when it comes to validation of marine materials? We already touched it, but I think we bring it up again, just to make sure that we don't leave it behind.
Do you want me to start?
Yes, please.
Okay. I think that for a global successful marine energy industry, this requires knowledge sharing and collaboration. And we have very good examples. I already mentioned some of them with collaborations at different levels. And I think that from all European funded projects in which WAVEC was involved and working with high-level organizations and also with partners from industry, I think we generated value exactly by working together. And there is a huge number of initiatives that involve the collaboration of organizations, researchers, and many of these technical challenges related with ocean energy development, like new materials. These are not device specific, so we clear benefit from collaboration. Exactly in this sector, in the ocean energy sector, I think we need to create a global critical mass of research and innovation to help to find the solutions to progress with this sector. So this means bringing together different perspectives, different experience, skills, knowledge. So important to help connect all these research initiatives across Europe and beyond.
Thank you very much, Anna. I pass the floor to Jose as well. Collaboration. Why is it so important for Plukan and the sector, I would say?
Yeah. For us, it's critical because here from the outermost regions, we are critically depending on the collaboration with industry, also with technological developers and so on. But I think that also at the European level, this is quite important, the opportunity that we have to get different environments where we can test simultaneously with, for example, here in the Canary Island, we can offer subtropical conditions that are especially for biofouling aspects. Also, we can provide testing materials, for example, in relation with the oil and rig industry. As you know, the base for the oil and rig industry operated in the North Africa is here in Las Palmas. So also at the same time, we are now starting in Spain with the offshore wind industry, where again it's critically necessary to test different kind of materials. We are also very much interested in everything related with testing new infrastructures for coastal protection. I think that in the near future will be critically important for mitigate climatic extreme events across Europe, but also across the world. Testing with new materials with much more environmental friendly aspects. So I think that is quite important to work together, also using European funds, like now in the European Europe program, working together and progressing faster at the European level in order to provide value to the world, to the Europe and to the world.
And then I ask next question then to the panel. So how do you see the collaboration? How do we collaborate in the future? How do you see the collaboration evolve over time? Is it sharing data? What is it that we need to establish together on the European level? Anyone who wants to answer this one? I'm not gonna pick one.
If I can answer, yeah.
Yeah.
I think we have to share data. For instance, at the French Corrosion Institute, we have developed corrosion sensors. I can show you one like this, and biofilm sensors also. This type of sensors, we have deployed it in many types of seawaters in the world, but not all, actually. We have started a collaboration with Kristineberg, exploring the differences in terms of corrosivity, biofilm formation between the two sites. So we have started this collaboration this year. And I really think it would be great to extend collaboration with other seawater stations, because we are not a lot of seawater stations in Europe, in order to better understand the differences. And for instance, in the first results we obtain, we can see quite large differences between the type of corrosion we can have, the biofilm formation we have between the two sites. So I think it would be very interesting to better understand and to map the corrosivity and biofilm formation using the different stations that we have in Europe. Yeah. So in this direction, I think we should increase this type of collaboration.
Thank you, Nicholas. Pablo?
Yeah, I fully agree with him. Collaboration in this global challenge that is blue growth has to be a global answer, a global response as well. So as he mentioned, and this was mentioned before, it's not only to test one material or one equipment in one place, but in the wider sites, the wider variety of sites as possible. So we already have placed some exposure sites also in Plocan, in the port of Taliarte in Gran Canaria. So we are starting to merge that network that is really, really important. And I think that we can collaborate with you guys in the future.
Thank you, Pablo. And if we're going to develop these sites and get the collaboration going, what kind of support do you see is important? Both could be from Europe and also the form of private investment or companies coming to the sites. Can you explore a little bit about the support that you need to develop your sites?
I think that we have to work more as an European distributed infrastructure. I think that this approach will be produce much more value to the market, to the research group, and also to the administration. I think that we have to try to use this approach in order to understand better what are the problems and needs, the gaps demanded by the industry and also demanded by the administration in order to move on the legislation. And having this approach of some support from European Union in order to provide this higher competitivity to the European industry, and also, of course, looking for additional research funds on research. I think that the research component should also be provided in such a way that certain groups, research groups especially, but also the industry can move on research activities. And finally, I think that another third part should be focused on the industry. I think that the industry itself should be contributed perhaps a little more in order to understand better what is happening with their products in the environment, in order to have much more friendly products and also to accelerate the innovation cycle.
Thanks, Jose. Is there anyone who wants to jump into this, what Jose is saying? No?
Yeah, I agree. Nowadays, the collaboration depends on the success of the proposals that we present together. Maybe it would be good that the European Commission finds another way of funding this infrastructure, so there's a more stable collaboration and among all the sites, not only those who participated in relevant projects also.
Yeah. Thank you very much. Another challenging issue I would like to address. In the emerging industry of renewable energy, for example, there's a lot of SME companies. And if you go to an SME and say, you need to focus on circularity in your materials, and they are busy to try and get their device function at all and prove that to financiers, etc., etc. How do we get the SMEs and the developers on board on circularity and sustainability pathways? Anna.
Okay, that's a good question. Because I understand that for developers, they have to deal with so many barriers and difficulties to progress with their technologies. But it's very important to understand that what is the impact on the environment. And Matthias Suede, indeed, in the beginning of this session, he spoke about the sustainable growth and what materials. It's important to see what materials we are using, and important to measure. This was mentioned, and exactly this test sites have a role to play here, because it's important to start from a life cycle approach and look into the opportunities for upgrading system components and extending the life of existing materials. This was indeed addressed by Oceanic project, where we look into we look to coatings and developing, extending the life of coatings, the paintings used. So I think at the European level, there is much that can be done to encourage these developments. For SMEs, it's important that they are aware that there is a social license to operate, and stakeholders have this type of concerns. So these concerns have to be addressed. So there is much to be done at the research on materials, on extending the lives of existing materials, and this is a very important topic for research, encouraging research in this area.
Thank you, Anna. We are closing in on this session, ending this session. I would like to hear, I think Jose was trying to raise his voice a little bit on this issue as well with the SMEs.
Yeah, yes, small comments. I think that the circularity is not an option. It's something that have to be from the very beginning I mean, it's not makeup. It's something that we have to start with. So at the same time, it's an opportunity for these companies. So I think that in the near future, we have to think that this is a basic constraint, a basic design variable that we have to include from the very beginning. It's not an option anymore to do something that works, but without respect of the environment. So that we have to change our mindset about that. Small and big companies.
Thank you very much, Jose. Thank you very much, Nicolas, Jose, Ana, and Pablo for joining in and to discuss this important issue, to collaborate on these things. The ocean is a challenge for us, and it's if we're going to be in there. So, and it's a regional challenges, specific ones. So this is a really good topic to, well, bind us together. So very much thank you. And I'll look forward to talk more with you in the future on different collaboration topics. I would like to introduce Olivier Rod. He was doing the introduction for RISE. He's the department manager for corrosion, and he would like to say some closing up remarks before we close the sessions for today. Thank you very much. I'll leave the floor to Oliver.
Yes, thank you, Pierre. And it was really an amazing mix of many different topics and presentations. So it's not so easy to make a short wrap up, but I will try to do it anyway. I think really got a good tasting about how Kristineberg will contribute to cross-disciplinary collaboration now. I will first take with me Matthias Suede from the European Commission about the importance of sustainable blue growth and how materials will play a key role there. So we really need to know what we put in the oceans to develop and to choose the right material for the right application. And it's not a single solution there. We have had example of many different types of materials: composites, wood, concrete, metals, coating. So in order to make the right choice, to develop the right solution, we need to work together through the value chains. And we had examples of different companies here working together, from material substance producers like Kebony, Boero, iTech, product solution providers like Volvo, Penta, Core Power, Ocean Harvesting Technology, NKT, and end users like the Port of Gothenburg. And it's not only many different materials, it's many different conditions also. So we need a broad international collaboration, like with WWF, Technalia, Plocan. Thank you for contributing also here. Some words regarding how the materials of tomorrow should be. Yeah, it should be durable, environmental friendly, that it doesn't release any toxic substances in the ocean. We have been hearing about lightweight materials, needing less materials, and also recycling, reuse materials. So it's a lot to work with and to develop. So finally, I really want to thank all the participants for today's event. We have been talking a lot about sustainable future, and seeing all the organizations present today working together give me a really good feeling, a good hope for our work supporting this sustainable blue growth. So thank you, all of you, and thank you for the organization of this event.
Thank you very much, and I've thanked all the speakers a lot through the sessions, and I will therefore thank all the listeners. So thank you very much for listening in to this this opening session of our test site here at Kristineberg, and you're all welcome here once the restrictions are eased up. And I look forward to see you in the future in different collaborations. Thank you very much, and I'll see you soon.